Imagine you had a universe which was a big universe. Then that's very big. And if you actually traveled far enough in that universe, you would start to see repetitions. You would start to see repetitions. You would start to see exact copies of 183. What the hell am I talking about here? I mean, to put it into perspective, you might ask yourself, well, okay, how many grains of sand could you fit inside this room? Okay, you think that's a lot, right? That's going to be a lot of grains of sand. It's only about 50, not that much. So you might ask, well, let's ask something more dramatic. Well, how many particles are there in the universe? Okay, now that's 80. That's how many particles there are in the universe. And you could ask yourself, okay, well, how many grains of sand could you fit inside this room? It's full of just grains of sand. How many grains of sand can I fit? And that would be about 90. It's quite a big number, but it's not that big. There's certainly stuff that's a lot bigger than that.
You're saying it's not that big a number, and yet all these things that we think of as big, like the size of the universe and atoms in the universe and particles, aren't even touching it. So it must be big.
Well, yeah, okay, but I can think of something that is bigger than it. That's physical, that you can think of physically. Okay, how many grains of sand could you fit inside this room? Okay, and you get about 183. So because we can think of things that are bigger. We start writing down 183. Okay, and let's suppose, well, we're writing on a piece of paper here, but let's suppose we actually try to write it down on particles. So for each particle, we're going to write down 183. First particle we write down, second particle we write down, and we carry on doing that on every particle in the universe. And we still would not be able to write down 183. It's too big a number. And there's something else remarkable about 183. So this I find this astonishing. Imagine you had a universe. This sort of emphasizes how big 183 is. Imagine you had a universe which was the smallest volume, something like, which is a Planck volume. So it's basically a little cube its radius is a Planck length, which is 10 to the minus 35 meters. Okay, so big universe, and in some models of internal inflation, things like that, you do get universes which could be as big as this. So we have a universe which is 10 to the minus 35 meters. Then that's very big, and if you actually traveled far enough in that universe, you would start to see this many meters away from yourself. Now you might think, what the hell am I talking about here, Brady? But you know, let's take you, Brady. Let's ask how many quantum states can describe the volume that you occupy, okay? Right, the number of quantum states that can occupy that volume, the total number is, and you can work this out, it's something to do with entropy and black holes and stuff like that, but you can work it out, and it is 10. That's a number of different quantum states, different ways that you could actually put together that volume of space. So let's say, so that number is less than 183.
So the space I'm in could be a dog.
It could be all those particles arranged in any number of different ways. Particles might not even be there. But all those possible states, given that volume that you occupy, the number that you could, the number of possible states you could have is 10. Big number, not as big as 183. 10 is equal to 10. Okay, so this number is clearly less than this number. Okay. So you occupy roughly about a meter cubed of space. There's that many different possible states that you could be in. Okay. So if you go this many meters away from yourself, you know, you would start to expect to see repetitions. So that means that if you're in a universe which is so big, as big as 183 meters across, then eventually you would start to see those volumes of 1 meter cubed.
So just by chance, I will run into another dog that matches me.
Exactly. Matches you exactly. And then, you know, you go even bigger and you would start to see those volumes of 1 meter cubed repeated. So this is truly remarkable. I think the fact that you would go there and see those volumes of 1 meter cubed, I think is just sort of emphasizes how big that number really is. But the size of the universe is 26 meters, sort of all cubed. That's the size of the universe. So this number is, you know, tiny compared to that.
So there's probably not another me in this universe.
Probably not. Then there probably is.